on, folks? It looks like nobody's here, but Justin Elliker, or not Justin Elliker, that's the guy coming in next time. Justice, what's your last name? It's like
Dennis Louis.
Yeah, Dennis. Justin JD is here, and he's going to be hanging out with us. I'm going to do some tutoring with him. We're going to go kind of. I'm going to put the pause button on teaching you guys new things. I actually finished teaching you all the way through Quad 8, and I think I'm pretty much done there. I don't think that there's anything else I need to really go through. But what I'll do is I'll go through each of these and show you how to do the homework. I'll do maybe a few of them for you, and then you guys can kind of get the hang of it. Cool? Quad 9, to be honest with you, like I said, once we get through Quad 8, Quad 7 and 8 are the heavy hitters. Quad 9, 10, 11, 12, 13, 14, I haven't even started doing homework on, like writing the homework for. And it's because I want to spend so much time doing this stuff. I might even go and redo homework for Quads 7, 8, or 7 and 8. Make more homework for you to do so you can get that extra practice. If you have that under your belt, taking these tests won't be so bad. Okay? Now, just as a general recap, Quad 7 and Quad 8 is doing the same thing. All we're doing is we're doing kind of a I realize. Hey, what's going on, Kaylin? What's going on, Shane Bex? I don't know why my computer's not sharing the computer screen. Let me start sharing it with you now. Can you hear my voice? Awesome. Let me share my computer screen with you. I'm going to be doing some general recap of things. All right? I'll probably be switching to a different screen, so I might not see you if you type up a question or anything, but I'll check it back every so often. Remind me to do that. All right? I got Justin in here. He's completely lost. You guys are not doing so bad, so I figured I would let you guys, not let you guys, but I figured you guys would be all right, and I'll, you guys can ask questions if you have them. Cool? Say cool. Or not cool. I don't like you. Or you're ugly. Or, yeah. Alright, cool. Can you see my computer screen yet? No, you cannot. It says it's sharing my computer screen. There's a blue line here which states that you can. That's not good. Alright, let me stop and start again. Whoa, what happened? Oh man, my stomach hurts so much. Check 1 2, check 1 2. Audio check. Audio check 1 2. Audio check. Alright, audio's coming through. Let's see if I can get the screen share to come through. Come on, screen share. Work, darn you. And we're including all of this in the YouTube video because, why? Well, because now you can see what Mr. Daldy goes through the pain Mr. Daldy goes through to share all of his stuff with you. Alright, let me know. Can you see it? I suspect you should be able to soon. Awesome. Thank you. Alright, so let's get this party started. Basically, we're doing completing the square. We're going to recap on completing the square and quadratic equations. Where would you say you're having trouble with, or do you want me to just start from the beginning?
It's like the beginning of part 2.
All right. Well, let's see what part 1 is. Did you finish part 1?
It's just square rooting.
Yeah, that's just taking the square roots.
Yeah, I think so.
All right. Okay, here we go. Let's preview it, see what it's like. By the way, this screen over here, this is where I'm going to type all the math. My computer that I use to write things on is completely on the fritz, so. Alright,
Oh, it was towards the ending of this one, maybe.
did you understand this? You can take
Yeah.
the square root of 16, square root of 49, square root of blah, 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 right? Alright. Now, you didn't understand these last parts right here.
Yeah, when it got to the bigger numbers,
Like square root of 81 or square root of 121?
the further down.
Like this?
Yeah, when it got to those.
Alright, well, let's talk about this one. The square root of, we have x squared equals 121, right? So really what you're going to do is, in order to get rid of, let me make that bigger so you guys can see. In order to make that x all by itself, you want to take the square root of both sides, right? Now, we're going to take the square root of this side and the square root of that side, and let's see what we got. Are we cool with that? Now, what you need to do when you take the square root of both sides is you need to remember to throw in a plus or minus. Ask me why. Or do you understand why? You don't understand why. Okay. We'll go down to Desmos. Actually, you know what I'll do is, before I do that, before I take the square root of both sides, let me just do this. What if I graph this function right here? X squared minus 121 equals, or I'll just say f of x. What if I were to graph that? F of x equals x squared minus 121. What would that graph as? What do you do to that graph? I'm looking at you, Shane Becks. What is it that you'll do to that graph in order to make it, or how do you graph x squared minus 121? I'm also looking at you. Do you know how to do that? Oh, come on. You guys know how to do this. This is old school stuff. You don't know how to do this? You just take a regular parabola and you move him down.
Oh.
How much do you move him down? 121. What more do you want from me? You know that, right? Right? That's not crazy stuff. But watch. All right, Desmos. Desmos.com/calculator. Let's go to that. Oh, how'd you not know that? All right. I'm going to desmos.com/graphing calculator. I'm going to type in my x squared, okay? There's a regular parabola, right? And if I put a minus 2 there, I just took the parabola and did what? Put it down 2. Now, if I set this equal to 0, what I'm asking is, when does this graph equal to 0? When does the height of this graph equal to 0? Where? Actually, you know what? I'm going to do a minus 4. Let's do that. When does this graph equal to 0? What x value gives me y value equal to 0? Where does the dang thing cross the x-axis?
-2.
At -2. And at +2. This is why you're taking the plus and minus, because when you're dealing with a square root, or when you're dealing with this x squared thing, right, it will yield 2 answers because you're dealing with a parabola. What is this? What you would do is you'd say, oh, okay, well, I would put 4 on the other side, and then I'd take the square root of both sides. And then what is the square root of 4? You would say 2, and I would say, yes, that is one of the answers, not both of the answers. There are 2 answers. There's 2 and there's -2. Does that make sense to you? All right. So really what we have is the square root of x squared, right? The whole point of doing that is so that we can turn that into just a straight up x, right? But we also need to keep in mind that we better, for good measure, throw in a plus or minus on that side. Why a plus or minus? Because there's two answers. Does that make sense? All right, use your handy dandy calculator, or if you know it off the top of your head, what is the square root of 121? Hint, I gave you nice numbers to use. 11. There we go. So this guy is 11. So the answer to this is both positive 11 and negative 11. So I think that when I ask you what are the two answers, you would have to say, oh, that's plus or minus 11. Now where is my... There it is. So the first answer is 11. The second answer is negative 11. I think I set it up so that you could put negative 11 in the first answer and 11 in the second answer. It doesn't really matter as long as you have either or one, as long as you have both of them. Never put a positive on things. If it's negative, you put in the negative, but if it's positive, you just kind of leave it be. Cool? All right. So even looking at this one, all right, this is exactly the same thing. Let's just do this. Minus 4 equals 0. Okay. Disregard the stuff below. I haven't deleted it yet. Alright. So, what I need to do to get x all by itself is first get rid of this 4. Does that make sense? So, I have x squared equals 4. Do you understand how I got it as x squared equals 4? How did I get rid of this negative 4? I added it because it's being subtracted off of the real thing, off the original thing. Does that make sense to you, Shane Bex? Yes, no, I can't hear you, I don't like you. Awesome, cool. I know that this is probably, stuff you did already since you guys are getting A's in my class, but, you know what I mean? Bear with me for a second. So, I put the 4 onto the other side by just adding 4 because it's subtracting over here, so I added it onto that side. Then I want to get rid of that square. What do? I take the square root of both sides, remembering to do what? Throw in that plus or minus. For me, when I program it, it's just /PM. When I throw in the plus or minus, I end up getting x equals PM what? 2. There we go. So you couldn't have gotten confused on these ones. Maybe on these last ones, 576.
Yeah, those ones are the ones.
All right, fine, let's do it. 2304. You already know the pattern. All I'm going to do is basically replace this with a 230. 230. It's the same thing. Use your calculator. What's the square root of 2304? 48. So the answer is plus or minus 48. That's it. I'm just dealing with bigger numbers, but I did give you access to a calculator, so you can't complain. Does that make sense? All right, cool. So let's go with 48 and negative 48, and we'll see what we got. What was my score? Oh, okay, wait, we're tripping it up a little bit. Do you know how to do this one? Why don't you walk me through this, okay? Delete this. All right, so let's write it down. 8 times x squared minus 392 equals 0. Are we cool with that? All right. How do I get x all by itself? What is the 8 doing to it? What is the 8 doing to that thing? To the x? All Alright, fine. I'll give you a hint.
Oh, it's multiplying.
It's multiplying. Usually we don't write that there. Whenever we have letters right next to a number, you assume that there's multiplying. Okay? Whenever you have two letters next together, like x, y, you would assume x times y. Or x, y, z, that's x times y times z. Okay? We're just too lazy to write it. What is the 2 doing to this x? It's squaring it. And what is the 392 doing to it? How is this 392 attached to this x? Well, right, that's what you have to do, but it's being subtracted right now. Okay? The way I look at this, I think of this kind of as an onion. Ogres are like onions, and onions have layers. And I don't even know if you're old enough to remember that quote. You guys know where that's from? Ogres are like onions, and onions have layers? What about a parfait? Everyone likes parfait. No one likes onions. You guys know what I'm talking about? How sad. Shrek, the first movie.
Really?
He's explaining to Donkey. He says ogres are like onions, and onions have layers. Okay? What I think of it, think of this X as being protected. Okay? And it's being protected by a square, like by that 2. And then that whole setup is being protected by the 8. And then the whole thing is being protected by this minus 392. It's kind of like if I have like a precious resource or a precious thing I want to guard, I would put my security around it in rings. Okay? I would put this 2 around it, and then the outer ring would be the 8, and then the outer ring would be the 392. Does that make sense? And it kind of like all of these things are attached to this X, and I want to get X all by itself. I want to get rid of everything, and there's layers around it. Now, I can't go straight in for the 8. Because imagine that. Imagine like, all right, I think in the movie Thor, you remember the first Thor movie? When he breaks in to go get his hammer?
Yeah.
He has to break into the fence first. Then once he's in the fence, he has to get into the compound. And once he's in the compound, he has to fight that huge black dude.
Yeah.
And then after that, he goes into the final center to get his hammer. Right? He can't go and fight the big guy before he gets into the fence.
Yeah.
Before he passes all the soldiers on the outside. Does that make sense? So what he has to do is he has to peel off the layers to get to the center. Now I know that you guys are thinking, wow, Mr. Dalde is cray-cray. Like he's crazy. He teaches math using this idea of tactics and strategy and all of that kind of stuff. And you want to know something? I'm actually working on something. I'll show it to you. It's pretty awesome. Now you guys are thinking, Matt, Mr. Dalde is super cray. All right, check this out. I like it. I don't know if you like it, but anyway. I'm writing a math textbook for my son. He's in 5th grade, but I'm going to teach him Algebra 1, the same exact algebra I'm teaching you guys. And I'm teaching it to him in a story. I'm writing a novel for him. And this novel has these robots that guard this precious X resource in layers. And I'm showing him how to peel off these things. Now, I know I'm going into some kind of digression, but hey, I've got 2 hours to deal with me. Okay? What I've been telling my son stories like this since he was 3. About these robots, about these X robots, and like how you have to peel them off in a layer, and there are certain rules you have to follow when playing the game, right? And he actually can solve for X. He can do what I'm asking you guys to do right now. Yeah, he's in 5th grade. He's 10 years old. I'm not trying to make you feel dumb, but what I'm trying to do is just, that's how I teach. Okay? So, when I approach this thing, the first thing that needs to come off is what? What is in the outermost layer? The 392. And how can you pull it off? Adding 392. But his favorite thing is you have to add it to both sides. You've got to play fair. So you add 392 to here, 392 to here. That will basically take this 392 and put them on the other side of the equation, making it a positive. Going from a negative to a positive. Switch the signs. So this is 8x squared equals 392, equals positive 392, but we don't even write the positive 392 because we're so dang lazy. What is the next layer of security around this x? The 8. How do we get rid of the 8? So we have x squared equals 392 divided by 8. By the way, you have the calculator in your hand. What is 392 divided by 8? I'm just wondering. X squared equals 49. That's what we're dealing with here. Got it? All right. Now, what do? What is the last piece of security that is blocking us from getting to our precious x? The 2. How do we get rid of it? You square root both sides. Not forgetting to throw in the plus or minus. And what is the square root of 49? 7. X equals PM 7. Are we cool with that?
Yeah, that makes sense.
Okay. The way I look at equations is like layers. And you know what the funny thing is? The really funny thing is? I'll show it to you. Why don't I show it to you? Because it's actually pretty cool. I used to teach at Leeward Community College, so I used to teach college. And I was one of those weird teachers. I still am. I don't think I'm a normal teacher. Justice is like, yeah. But look, this is a textbook I wrote for algebra, or for calculus. I'm doing the same thing for algebra, but you know, it's kind of taking a long time. Anyway, this is my calculus textbook, and it's a story about my daughter. The algebra one's a story about my son. But what's really fun about it, what's really cool about it is I use the same ideas about layers and monsters, and there's a story that goes along with it. It needs a lot of work, but hey, I've got a lot of time before my 6-year-old learns calculus, so, you know, I'm going to work on it until it gets good. But there's these ideas about these layers, and I say, okay, well, what you have to do is peel off these things like layers. Now, the reason why I'm sharing this with you, it's not because I intend to teach you calculus, by no means. I mean, maybe one day, if you ever get up to that high math, and I end up being a teacher for that type of math, although we do have a full-time math teacher who's actually a great math teacher. His name is Mr. Lovin. He's awesome. And he teaches the calculus for now. What I'm saying here is that when I teach calculus, I teach them this concept of layers because taking a derivative and using the the chain rule, that's what it's going to be called. When you take a derivative and you use the chain rule, and this is, you know, first year of college probably for you, you're going to realize, oh, wait a second, it's to me, when I look at it, I see this thing as like peeling off these layers of security and getting to the center. And you have to deal with each layer. So, this weird way of teaching you, my weird way of teaching you very often has a reason. You might not see the reason, but it does. Does that make sense? Just like, remember when I asked you to give me everything in standard form, whenever I asked you to solve a quadratic, I would say, what is A, B, and C? You know?
Yeah.
And you didn't understand why I did that, or what was going on, or that was harder, you know, than just give me whatever answers I'm asking for. But the reason why I did that is because I want you guys to be getting used to identifying A, B, and C, so that later on you can basically use the quadratic equation. Because now, after we finally reach quad 8, you guys realize, oh, okay, Mr. Dalday had a point. All right, anyway. Lots of talking. Let's move on. Okay? We good with this quiz? That's not hard. So what was hard about it?
Just ending.
Just understanding how to solve an equation? Well, that's basic stuff. You better know that in and out. All right. So once we get done with square roots. So Shane Beck's, the reason why I'm telling you also this story is because I don't want to waste your time either. I feel like if you guys eventually you'll probably go off to calculus, and I want you to hear these stories. This is really the same thing. You're just adding one more complication to it. Oh, it looks like I have to fix that one. All right, let's just pull up in a random one. Let's try the hardest one, okay? All right. 7. X minus 43. Square that sucker. Minus 252 equals 0. Okay, you ready? Let's talk about it first. Identify your x. You got it? What is the closest layer of protection around that x? Inside the parentheses. Good. Good. It's kind of, perfect. So what's inside that parentheses? The minus 43. It's almost like there's x and there's like a bodyguard standing right next to it, and his name is negative 43. Got it? What is the next layer of security?
Square root.
Well, not the square root. It's a square, and you're thinking in your head, well, how am I going to deal with that? By doing what? Taking the square root. Good. What is the next layer after that?
7.
The 7. And what is it doing? Is it dividing? Is it multiplying? Is it adding? Subtracting? What is it?
Multiplying.
You got to speak up. No one can hear you here.
It's multiplying.
It's multiplying. Good. What is the next layer of security after that?
The negative 252.
Negative 252. So what we need to do in order to attack and get into that x, we need to get rid of the 252, then the 7, then the square, then the 43, and we will have x all by itself.
Okay.
Does that make sense?
Yes.
That's exactly what you do. All right, so do it for me, Justin. I'm not even going to tell you what to do. You tell me what to do.
The 252 becomes positive.
All right, I see what you're saying. You basically want me to take this, put an equal sign right here like this. Is this what you're saying?
Yes.
Yes. All right, now what?
You multiply divide the 7 from both sides.
Good. Frac 7.
It's
Oh, by the way, 252 frac 7, or I mean, not frac, but 36. Okay. Just wondering. $36. Good. I like it. What else?
Then the square.
Take the square. All right. So that is what?
You square the negative 43.
No, you square. Okay, here, look. You square root everything on both sides.
Oh, okay.
Like that. So, is that right?
Yeah.
Wrong. Forgot something.
The plus or minus.
Don't forget to put in the plus or minus whenever you take the square root. By the way, just to let you know, if you do that ever again, I'm going to boot you in the face
Okay.
with my foot.
Okay.
All right. So what that square root on the left-hand side is it peels off that layer of the square. So you can kind of get rid of that like this. By the way, what is the square root of 36?
6.
Okay, so I'm just going to, instead of writing the square root of 36, I'm just going to write 6. Are we cool?
Yes.
All right, now, what is the last piece of the puzzle that I need to get rid of in order to get x all by itself?
Parentheses.
Well, parentheses you can just ditch because it's not really doing anything.
Add 43 to both sides.
Add 43 to both sides. So on the right-hand side, you have positive 43 plus or minus 6. What up, dude?
Do you know if you have any dice?
Actually, I might.
Sorry.
No worries. Just this. I'm going to look for dice real quick. Miss Sononini is probably going to be gambling, and I want you. Here's what I want you to do. All right, this thing's recording right now. I want you to go through each step and tell the recording what each step means, why you did it.
Sorry, Justin.
So,
It's like, thanks. You suck.
It's okay, I'll try my best.
Yeah. Yeah. Oh, God.
no, they threw up way more time. They threw up like 20 times over the course of the day. Yeah, I was actually worried about dehydration.
You make the 252 positive, and then you
Sorry,
No, it's okay.
I don't know where my
divide the
Don't worry about it. I'll run the
7.
Sorry, negative. No dice. All right, hey, get out of here.
I don't know how to explain
You don't know how to explain it.
I know how to do it.
Well, you said unless you know how to explain it, you don't really know how to do it. Where are you stuck?
Right here, I don't know how to explain that. You just square root both sides.
Well, what you're trying to do is you're trying to get rid of that square, and that what is that square covering?
The
Everything in that parentheses. So what should you square root?
x minus 43.
Everything in that parentheses. Does that make sense? All right. By the way, I'm not worried, but I was just wondering. Do you know how to deal with 43 plus or minus 6? What are my answers?
Plus or minus 49.
Plus or minus 49. Wrong.
And I don't know how to do it.
You don't know how to deal with it. That's fine. 49 is one of the answers. And that, how did you get 49? I can tell, actually,
I just added.
you added 40. Yeah, 43 plus 6. That would give you 49. So you took care of the positive. Now take care of the negative. What is 43 minus 6?
37.
So your two answers is 49 and 37.
Okay.
That's how it works. Does that make sense? Yeah. And then if I were to Desmos this thing, what is it? 7. I'll just delete this. 7 x minus 43 squared minus what? Minus 252?
Yes.
Alright. Graph that for me. Zoom out. Oh, look. Okay, there it is. This is a parabola. It's a very sharp parabola. Let's zoom in, though. Where does this thing cross the x-axis at?
37 and 49.
Perfect. So our answers are going to be both positive 37 and positive 49. All right, let's see. What did that score? Dude, those are like
Yeah.
even bigger than the fuzzy dice you put on your dashboard. Where'd you get that?
Marlet.
Yeah, she's cool like that.
She's got so much stuff.
She's one of those classic teachers.
Yeah, big time.
Yeah, that's way better than the dice I would have given you. I would have given you small dice that you couldn't show on screen or whatever. What's your lab today?
We're just doing a little modeling natural selection. So we're doing evolution, and there's not a whole lot of lab opportunity for that, except other than modeling.
Yeah. All right, so you got quad part 2. You got the one that we just did. And it's not so bad. Shane Bex, how we doing? Still alive? All right, good. So, moving on. Quad 3, okay. Find the coordinates of the vertex of the transform. Okay, all right, here we go. This is actually really easy. I'll show you how to do it. Okay? We'll go to a hard-looking one. All right? Now, can you find the intercepts of this function right here?
Just by looking at
No, not just by looking at it, but I mean, do you know how to find the intercepts of this function right here?
it.
I'll show you. It's actually really easy. Once I write it down, you're going to be like, oh, that's all you do? Okay. 3 times x minus 16. I'm going to write the problem down. That's step 1. Write the problem down. Okay, wait. This is a bad problem. Let's move on to the next one. I'm sorry. All right, let's do this one. -3. This is an 8. This is a +7. Got it? Oh, and then I'll put equals f of x. We cool? All right. To find the intercepts, it's very easy. Whenever we want to find the x-intercepts, and that's what we're really calling is the x-intercepts. Whenever you want to find the x-intercepts, what do? Do you know? The x-intercepts basically mean, look at this. This is an x-intercept, 37, 0. 49, 0. What's in common between those two x-intercepts? The 0. The second number is 0. I mean, by definition, your y value has to be 0 if it's crossing the x-axis, because that's where it crosses the x-axis. Does that make sense? So, I mean, since it's the x-intercept, y has to equal 0. Does that make sense? By the way, f of x is often written as y. Back when we were doing lines, we were doing y equals mx plus b. You can also change that to an f of x equals mx plus b, but those were interchangeable. So what you're telling me then is just to say, okay, well, that's 0. Right? Now do you know how to solve this? I'll give you a hint. Look at the example we did 5 minutes ago.
So you just solve this.
It's just the exact same problem we did. You set it equal to 0. Okay, let's do that. So, tell me what to do.
You get rid of the positives.
Good, good. So, take this and make it -7 on the other side, right? Awesome. Now what?
Then you divide the -3.
Divide by -3. So what is -7 divided by -3?
Yeah, I mean,
It's 2.3.
2.3. Why'd you tell me positive 2.3?
Because does that rule apply to dividing too?
Yeah, because a negative divided by a negative is a positive. Yes, absolutely. I agree with you. Positive 2.3. Now what?
Then you get rid of the square.
Good. Good.
You put plus or minus in front of
There we go. I was waiting for you to say that.
um,
Here, look at this right here. My writing is a lot nicer than yours.
yeah.
No, I mean, it's not because my typing is a lot nicer than yours. It's because I kept it a little bit more organized than you did. You lost your equal sign somewhere.
Yeah, I did.
Don't lose your equal sign.
Okay.
Understand what you're doing and where you're putting things. But look over here. What do? What is the goal here? What was the whole point of what we're trying to do?
To get x by itself.
To get x all by itself. What's stopping x from being all by itself?
Then negative 8.
So what should I do to it?
Add 8.
Add 8. There we go. So I end up having I put the 8 on the other side. 8 plus or minus the square root of 2.3. Pray tell, you tell me what the answer is. I'm going to go talk to Manny. I'll tell you what, Shane Bex, can you help him out? Here's what you can do for me, Colette and RK and Coco. Here's what you can do for me. He's going to... Is the audio still coming through? Hello? Alright, good. I want him to tell you what his answer is. He needs to have 2 answers for this, and you guys tell him if he's correct. Alright? Alright, go for it. You got your calculator? This should take you a minute.
Okay.
I don't think you should let the work take your work. I have what's in my class. Just like my teacher.
Hold on 2 seconds.
I know each other.
you do?
Yeah.
Are you serious?
Yeah, I used to have to train with that.
That's Bruce Lee, right? A hitman.
Yeah.
It's
It's all about walking and walking and time.
at the same time holding it.
Yeah.
I'd love to learn that stuff. How far did you get?
I did it as part of my Screama. So I did a lot of it Screama, but then like the idea was with the Screama, usually with martial arts you start with nothing and you build up to weapons. With the Screama, you start with 2 sticks, 2 machetes, and then you go down to 1 machete, and you go down to knife, and then you go down to hands. So you do it reverse.
One of my friends were
Because I guess the idea is learn to fight with a weapon, and then learn how to disarm people who have weapons. So that's why we had to learn Wing Chun, because the Wing Chun was part of the hand-to-hand part.
yeah.
But that was 60 pounds ago. Come on, dude. You giving them an answer or what?
I'm insulted. I'm confused at the decimal.
All right, I'll tell you what. Kay, Coco, he's confused. Can you help him out? You got to talk to them. You got to tell them your problems. And Coco and Kay, this is the reason why I'm saying this is because this is a way for you guys to tutor him. This is a way for you to make sure you understand it. They say nothing. No help for you, Justice. Hey, Justice is a nice kid. Help the boy out. Do you guys not want to help him out? Give me an answer, that way I can know if you guys hear me or not. They're not even answering. Oh. Oh, she's helping you out by giving you an answer. She got 6.4 and 9.5. All right, I'll help you out. What is the square root of 2.3? 1.5. It's just some number, right? I mean, that's all it is. All right, so really what you're dealing with is write two equations down. Write 8 plus 1.5. Are you sure it's exactly 1.5?
It was like 1.5 something. It was 1.516575.
All right, write a few of those numbers down. So it's 8 plus 1.5165. All right. How's it? 1 point. You need to make sure there's a point there. And I usually write it horizontal. Just put 8 over here. All right. And then underneath that line, write 8 minus 1.5165. Okay. Now use your calculator for that. What is 8 plus 1.5165? All right. 9.51. Okay. Do the next. I find suspect your answer for 6.4. I guess you can argue that it's 6.49, right? Or 4.8. But if you were to round it off to 2 digits, technically you should report 6.5. I would try to report as many digits as possible. I think the computer truncates it off to you. But I accept answers within like 1,000th of the thing. So if you can get the 2 decimals or after the 2 numbers after the decimal place correct, then I'll say okay, it's correct. I don't really care about the rest of the numbers because that's too accurate for me. You guys got it? So I don't know for 100% sure, but I suspect that if you put in 6.4, you might get it wrong. I'll tell you what, there's a good way to find out. We can just check it. Oh, we didn't even solve the problem yet. All right. So our answer here is 6.48. Yeah, we'll just say 6.48. And then our answer here is 9.52. Are we cool? So, here's what I would say. If you know the 2x intercepts, if you know where the thing crosses at one point and where the thing crosses at the other point, and I'll tell you what, let's go over to decimal, so let's plug this thing into our calculator. It was -3 plus our x minus 8, right? Plus 7?
Yes.
Plus 7. Where's our graph? Oh, there it is. If I zoom in here, it crosses at 9.58 or 53 and 6.472. Good. That's kind of close to what I wanted it to get, right? If I'm asking for the vertex, where is the vertex located? Where did I tell you the vertex was located? Look at the vertex. It's right there. is the point of the parabola, and where is it right between? I realize there's an easy way to solve this, but I'm actually telling you to do it this way, okay? Where is it right in between? Our two x-intercepts. So if I want to find out the middle point of exactly our two x-intercepts, what should I do? How do you find the middle point of two numbers? You know? Shanebex, do you know? How do you find the middle point of two numbers? You should have learned this in like 8th grade. I'll tell you, you average them. You add them together and divide it by 2. Why do you divide it by 2? Because you added 2 numbers together. If you want to find the middle point of 3 numbers, you add all 3 numbers together and divide by 3. This time we only want to find the middle point of 2 numbers. That is equal to 8. So our vertex is at 8. We know that our vertex is at 8. We found the x-intercepts, then we use that information to find the center of the vertex. Does that make sense? Then, in order to figure out what we want for the y value right here, we just take this number and we plug it into here. In this particular case, we're dealing with negative 3 times 8 minus 8 squared plus 7. What is that going to equal to? Do you know? What is 8 minus 8?
0.
Square that.
0.
Multiply that by negative 3.
Negative
3 negative 3 times 7 times 0.
0.
Still 0. Add 7 to that.
7.
So your answer is 7. Right? So our answer here is 7. Are we cool? Now,
Yeah, well, she was going to, I don't think she was planning on putting us here.
there is an easier way to get these numbers right here, or at least this 8 right here. You don't need to solve it in reverse. You don't need to go x-intercept, x-intercept, and then take the average. There's a much easier way. Would you like to know? This equation right here is a quadratic in vertex form. It's a quadratic that I can graph easily in my head. What does that 7 do to that quadratic, the parabola? Do you remember?
Moves it up.
It moves it up 7. What does this negative 3 do to it?
Flip it upside down.
It flips it upside down. What does the 3 part do to it?
Makes it skinnier.
It makes it skinnier or vertically stretches it.
I'll just tell
What does this minus 8 do to it?
I'll just,
Moves it left or right.
all right,
All right. In particular, what does this thing do?
so, yeah, no big deal.
Move to the right 8. Hence, you got a parabola that is moved up 7, right? It is moved to the right 8, right? Flipped upside down and probably looks skinnier than a regular parabola. Here, let's take a look. That's a regular parabola. Which one looks skinnier?
Right.
Yeah. All right. So, would you agree that that's our thing? What we did was we took a regular parabola, we moved him up 7, and we moved him to the right 8, right? Then flipped him upside down, then made him skinnier. But where did his vertex land? At what point?
8.
8, 7. So literally what you can do is if you want the vertex part of this, you can read it off of here. 8, 7. Now, why did Mr. Dalday make you do it the hard way? Why did I make you solve for the x-intercepts, then take the average of it to find this value right here, then plug that into your original equation to find this number right here? Now, I'll tell you why. Because even though it's easy to read the vertex when you have an equation in vertex form, Your equations won't always come in vertex form. Later on in Chapter 8, I'm going to give it to you in standard form. And would you like to know how to solve it in standard form? You use the quadratic equation to find the x-intercepts. You take those x-intercepts, you average them, and you find the x-coordinate of the vertex. You take that thing and plug it back into the original equation, and you get this. You do the exact same technique I just showed you. So that technique works for any form of that equation. It works for everything. If I were to just say, oh, you can just read that as 8-7, or this as 16-9, then, you know what I mean, I would teach you for now, I would teach you for this homework, but you would get lost later on. What I'm trying to teach you is the concept of what we're doing, the concept behind what we're doing. Does that make sense? All right. You think you can do these?
Oh, yeah.
All right. Let's do this. All right, let's try. Okay, there we go. Oh man, my stomach is so sore. It's like a sharp pain. Ooh, I feel like I got to burp or throw up or something. Pass me those Tums. Thank you. I'm going to need you to take 2 to 4 tablets. 4 tablets, what is that? Tums tastes terrible. Shimbex, I'll tell you what. If you guys want, you guys don't need to stay. I'm probably only going to cover Chapter 7 with him today. I want to get to Chapter 8, though. Alright, so you need to watch this video completing the square. You know how to complete the square? Well, let's see. Where are they left? Well, only one of them left. Alright. Alright, solve for the variable and put your answer in. Okay. Complete the square is a technique that we use. And it's that weird one where I say put a blank in, then put some number in there. You know what I mean? Do you know why we do that? Okay. Let me think. Alright, for now, I want you to go back and watch the videos again. As to, I think the video that I'm referring to is this one right here. It's got to be it's got to be this one right here. I bet you it's this one. Complete the square. Watch that video. It's worth 10 points. Do you watch the videos? See, I'm going through the grade book, and I kind of give like relax, like I don't grade everything, but like if it's a watch video, I'm deadly on those. You watch the videos. I take the time to record them, to upload them, to all of this kind of stuff. So at least watch them at the very least. Anyway, watch this one right here. Okay. For now, I'm not going to tell you why we do what we do. But I did take the time to explain why we do what we do. For now, I'm just going to show you what we do, okay? Which most teachers, that's what most teachers do anyway. That's all they give you. They give you, this is how to do it. They don't tell you why we do it. I did take the time to do that. We don't have that time now. X squared plus 6x equals 7. Got it? What I'm going to do is I'm going to rewrite this problem. I'm going to put a giant space in there. It's weird. A weird space in there. Got it? Now, what number am I going to add? Or I'm going to add some kind of number over here. X squared plus 6x. Let's see, how do I take this? X squared plus 6x. It would be nice if I could turn that into x squared plus 6x plus 9. Do you understand why?
Because you could use 3.
Try factoring that. X plus something plus something. This goes back to factoring. You know what number should go here? Should be a number right here. 3. And 3. Because this number times this number equals 9, and 3 plus 3 equals 6. Does that make sense? In fact, I can write that, since it's x plus 3 times x plus 3, I can write that as x plus 3 squared. Does that make sense to you? So, darn, if the left-hand side had a plus 9, I would be happy. And by the way, where did I get, there's a relation between the 6, 3, and the 9. Would you like to know the relation? This number down here is always going to be half of that number over here. Like, you're asking me, where did I get the 9, right? I'll tell you. This number right here is always going to be half of this number over here. This number over here is going to be square of this number over here. So, if you start off with 6 and you want to get what number you add, you divide it by 2 and you memorize that number. What number is that? 3. And then you square it in your head and you say 9. Oh, cool. I know what number to add. And then it would be so convenient if I had a plus 9 there. So I'm going to put it in there. Here's the thing, though. You can't put it in there. You can't just say, I'm going to add one thing to one side of an equation.
Well, what teacher, what class?
That's changing the equation, right? That's not being fair. So I'm going to do something very clever. Instead of adding 9, I'm going to do 2 things. I'm going to add 9 and subtract 9. You see? Look right here. I'm going to add 9 and subtract 9. What is 9 minus 9?
0.
So what am I really adding?
0.
Am I changing anything if I add 0?
No.
So adding 0 is totally allowed, right? And that's all I did, was I added 0 in a very clever way.
So it's still the original equation.
Yes. All I'm doing is I'm saying, okay, yes, I added 9 and I subtract 9. I did the add 9 because I really liked this first 3 things right here. Those group together nicely together. Does that make sense?
Yes.
There's an extra parentheses in there. All right. Because these 3 numbers turn into this, right? And that's not hard to see. So you still have your minus 9 out there, right? Because that minus 9 was left outside of those 3 numbers. You still got your equals 7 over there. Cool?
Yeah.
You can solve this. You can get x all by itself. I'll show you. What is the x being protected by? Tell me the order.
The 9.
The 9. What else? No, tell me the order starting from the innermost circle, work your way out.
Oh, it's getting protected by the square.
No. The 3 first.
Oh,
Because the 3 is inside that.
okay.
When I teach this to my son, I call these force fields. That 3 is inside the force field. And the square is outside the force field. So you have to get rid of the square before you get rid of the 3. And then outside of that entire thing is the negative 9.
So it's the 3 first, then the square, then the negative 9.
Well, no, it's the 9 first, then the square, then the 3. You need to get rid of the outside and work your way in. Does that make sense? So this negative 9, you're going to add 9.
to both.
Alright, that's easy enough. 7 plus 9, 16. So it's this thing equals 16. Instead of just putting plus 9, I'm just going to put 16. That's all right. Alright, now what?
Then you square root both sides.
Okay, that's nice. Let's do it. So that's 4. And I can get rid of the square part, right? Am I good?
Someone.
Plus or minus.
There we go.
As we get things down.
Why plus or minus?
Because it's 2.
Because I took the square root of both sides. Whenever you take the square root of both sides, you add the plus or minus in. I didn't take the liberty of drawing the square root, but I figured you'd kind of catch on by now. Now what?
You get rid of the 3 by adding 3 to both sides.
No, you don't add 3 to both sides.
We call that.
Who's on what?
Candy for that?
You minus 3.
Yeah.
There we go. X equals negative 3
And you missed
plus or minus 4. So X equals what? There's 2 answers.
What was it for 6th grade? Yeah.
What is negative 3 plus 4?
It was fun. It was a lot of fun.
1. X also equals negative 3 minus 4.
Should be minus 7.
Negative 7. Perfect. That is your 2 answers. So I asked you the question twice, and I said put one of your answers here, put one of your answers here. So one of these is going to be 1, and one of these is going to be negative 7. Doesn't matter which one. This could be negative 7, this could be 1. The computer should grade it for you the same. We cool? Now, let me show you a hint, a trick, all right? These numbers came out to be nice numbers. They didn't come out to be ugly decimals. Because they came out to be nice numbers, there is a faster way to solve this. Would you like to see it? The faster way to solve this is I'm going to straight up put the 7 onto the right hand side, okay? X squared plus 6x minus 7 equals 0. We cool? I just took the 7, put them over. And then I'm going to try factoring it. Let's just try it. See if it works. X. Alright, I need 2 numbers to multiply out to be a negative number. So one of them has to be positive and the other one has to be negative. Right? This is factoring. This is back in quad 3, quad 1 or something like that.
Would be positive 3 and negative 3.
Positive 3 and negative 3. Does positive 3 times negative 3 multiply out to be 7 though? No. We need 2 numbers that multiply out to be 7. Which is nice because there's only 2 numbers that multiply out to be 7. What are those 2 numbers? What times another number will give me 7? 7 times 1. Now I need them to add up to be 6. So which one is positive?
The 1.
The 1 is not positive. The 1 is negative. Because it's positive 7 minus 1. Because positive 7 minus 1 is positive 6, right? Equals 0. Right? And then, oh, so you're saying x plus 7 equals 0? Or x minus 1 equals 0? Right? That's what you're telling me? Remember when we solved these? If you get into factored form, either this first one equals 0 or the second one equals 0?
Yeah.
So that's what I'm saying. X plus 7 equals 0 or x minus 1 equals 0. So this translates to x equals what? Negative 7. And x equals? Perfect. So our two answers is negative 7 and 1. Look at our two answers. Negative 7 and 1. Which way was easier? The factoring method, right? And you're thinking, well, why don't we solve all of them using the factoring method? That doesn't make sense. Why are you making me do this the hard way, Mr. Dalday? And my answer is this. Is because the factoring method only works out nicely when your parabola x squared minus or plus 6x equals 7. Let's just put it onto the other side. Minus 7 equals 0. All right. The factoring method only works nicely when these answers land nicely on integers. But if this were an 8, then where does it land? Yeah, 1.123. It lands on a decimal. So if I make that small change, factoring doesn't work anymore. Factoring cannot save us. But guess what can? Complete the square. So complete the square always works on quadratics. Factoring sometimes works on quadratics. This is why I taught you factoring first, because it was the easier way. What you should do is you should do enough of these problems to get used to it so that you can say, oh, I can factor that. That's nice. But what I want you to do, I mean, I guess that's, you remember me talking about the bazooka and the fly swatter. Do you understand that discussion now?
Yeah. You said a bazooka can kill everything in a fly swatter.
Completing the square, the first way we showed you was the bazooka. This is harder to use. It's more of a pain to clean up. But it always works. I guarantee it. This is easier to use. It's shorter, it's prettier, but it's not as powerful as a bazooka. It's a fly swatter. Now, if you're dealing with flies, you'll want to bring a fly swatter. You don't want to bring a bazooka. But if you're dealing with wild boars, you don't want to bring a fly swatter. You want to bring a bazooka. You know what I mean? Is there one that will always work? Yes, the bazooka will always work. But it's not always the best option to use. So get good at using both. That's my answer. You want to know what else is a bazooka? I mean, it's the exact same bazooka, just packaged a little different. The quadratic equation, the negative boy plus or minus, the radical party, that's the boy was a square, minus 4ac all over 2a. That's also a bazooka. That's the exact same bazooka as completing the square. You got it? So like if I did this one, x squared plus 4x minus 1, let's try talking about that one. Do you see why I wrote down x squared plus 4x minus 1 equals 0? In this case? I just put the 1 on both sides, on the left-hand side. And became a positive 1 to a negative 1. Try factoring that. What are two numbers that multiply out to be the number 1?
1 times
1 times 1. Can you think of any creative way to add them to get the number 4?
3 plus.
No. I'm talking about use the number 1 and use the number 1 and add them together to magically get 4. No. You know why you can't think of it? Because it doesn't exist. You know what? This problem right here doesn't work with the factoring method. You cannot. I would be very impressed if you could guess the two numbers that would give you two numbers that multiply out to be 1 and add up to be 4. Do you see this? So we have a problem. So what we do is we right after the x term, we put this weird space. You see the space? Andre,
Sorry I wasn't in class. My brother had to go to the DMV.
it's all right. You know what? Here's what I want you to do. Andre, how long are you going to be working here for?
This class, and then I have to go after.
What's your next class?
This is just biology.
Oh, okay. All right. You sit in biology then. I was going to say sit in with just. Do you have to go biology?
No, I dropped out of biology.
Oh.
I was failing now.
Dude, you got to catch up, man. All right. You put in this weird space. What is the number I'm going to put in that first column right there? What number should I add to it? Darn, it sure would be convenient if I had a plus what? What are the rules? You take this number,
You subtract.
you divide him by 2. So what is 4 divided by 2?
2.
Then what do you do? You square it. So what's 2 squared?
4.
Darn, it sure would be nice if I had a plus 4 over there. Right? Because x squared plus 4, what are 2 numbers that multiply out to be the number 4?
2 times
2 and 2. And what are 2 numbers that add up? Or can you figure out some way to add those 2 numbers together to make positive 4?
2.
Yeah, you just add them. 2. Right. So do you see how convenient that would be if there were a 4 there?
Yeah.
But you're not playing fair.
You have to add both sides.
Not necessarily add it to both sides. I'm going to subtract it from the same side. It's the same thing as adding from both sides. If I put that 4 onto the other side of the equation, I would have to add it to that side. So it would be plus 4 over here, plus 4 over here. We're good. Does that make sense? All right. See those first 3 numbers? As you told me, that's x plus 2 squared. These first 3 numbers, x squared plus 4x plus 4. I still got the minus 4 and I still got the minus 1. By the way, I can combine those two. Minus 4, minus 1, that's also known as negative 5. We cool? You sure? Ask me. Come on. Where did I get what? I'm lost.
Where did you get the... I'm lost with the negative.
A negative 5. That's pretty straightforward. These first 3 numbers is the same as x squared plus 2 squared. I'll tell you what, write down in your paper x plus 2, and then put a parentheses around those, and then write x plus 2 again. Alright, now FOIL that. FOIL it. First, outer, inner, last. Hey Sarah.
Yeah.
I'm gonna do another lab with Justin. I'm sorry. Is that alright? I can do it. We're gonna go to the roller coaster with the loop loop, and we're gonna use the speed to capture the speed at that bottom of the ramp.
Okay.
I'll try to. I can do it in the hallway.
Okay.
Okay. So thank you for confining me in a small slight space with Justin Ellicker.
Well, it's not you.
Maybe x squared plus 2x, or plus 4x when you combine that.
Yeah. X squared plus 4x plus 4, right? See, I told you, these 3 numbers right here, this thing down here is the same as those first 3 numbers. Right?
Yeah.
We still got the minus 4 and the minus 1 on the outside, right?
Yeah.
Can I combine those? That's where I got the minus 5. We cool? How do you get the x all by itself now?
You square root.
Nope, not yet. You're attacking the middle guard without attacking the...
So you have to get rid of the 5 first.
Get rid of the 5 because he's the outside guard.
So you move 5.
I almost want to look up Thor getting his hammer back. I almost want to look at the clip.
It's like so different white, and so it's like the colors are kind of subdued yeah.
That's not Indians.
Yeah, that's interesting. Thor gets his hammer back full scene. Extension.
So cases, I think too late. If they're not this summer, then you should think about it. So it's
No.
like
Thor hammer time.
5,
I'll probably what I'll probably do is
We all be in our movie at the moment. Until somebody corrects me, I'm sure they will. We all, this has given us some of the most iconic and spectacular. Charlie had done a lot of variations. He did probably like 60 or 70 different variations at the very beginning of the project. I paid a lot of attention to paying homage to the Viking era, which is all the Norse mythology that Thor is based on.
no. I want to see where he like.
$1,000, and you get 4 college credits. And if you come back the next summer,
I want to see where he breaks in,
you get paid.
and then what I'll do is I'll probably have you guys watch that part of the movie. Like this is the concept that I'm kind of talking about.
But you could also,
You know, this idea of security, layered security.
so
You know which scene I'm talking about,
Yeah,
right?
where
All right.
he has to peel through the fence and then crawl through the mud and find his way through the compound and fight the big dude first before he gets to the hammer.
Yeah. That's exactly what I'm saying. Is he's got to go through the fence. He's got to break into the plastic sheet compound, which I always thought was dumb.
Yeah.
And then he has to fight the big dude, and then get to hammer. This is the fence. Here's the plastic sheet, and here's the big dude. You need to get through. You cannot go straight for the big dude because you got to get through the fence.
Yeah.
You cannot get through to go straight for the big dude. You cannot go straight for the plastic sheet because you got to get through the fence.
So,
You'll find when you take a derivative, when you take a derivative and you hit this thing called the chain rule, you're going to have to think in the same exact mode. Or at least, I find that my calculus students have a great advantage when they think in that way. All right, I'll tell you what. You can finish that on your own. You can do the rest of these. Complete the square. It's really just a lot of practice doing the same thing. Have fun. Quad 7. Complete the square. Really, once you know complete the square. Okay, let's see. All right, here we go.
So you were here freshman year, right?
Oh, this part 4 is actually teaching you how to get the number that you need to use to complete the square. In this case, that number is like here. What is the number that should go here? If I can make that, darn, it would be convenient if that C were a what number? What's going on, Justin?
Why are you holding left class?
Yeah, I want you to go in the hallway and start building a ramp.
a 6.
No, not a 6. You
A
take that
ramp down
6
the
divided
stairs.
by the 2.
Down the stairs.
No, let's build it over here.
A 3.
You divide it by 2 and then you square it. 3 squared.
But you get
Is
4
not.
college credits.
Darn, it would be nice if we had a 9 there.
So each
What
credit
about this?
each costs
16.
It would be nice if we had a 16 there. You're getting the hang of this.
So, you know,
What about this number right here?
You divide that by 2, which would be 9, and square that would be 81.
Well, you divide negative 18 by 2 is negative 9. And you square that, but it still is positive 81 because negative 9 times negative 9 is 81, so that doesn't matter. That's it. That's all you. That's it.
Okay.
All right, what about this one? That one's tougher.
So you go and you, so they'll like, they go and they'll go like, for example, the Boston, right? Let's say you guys are studying.
Negative 13 square rooted would be.
It's like 169 over 4.
You would do like a half of dime,
How did I get that?
like run a transcend
It's very simple.
plus the different areas along that.
What's 13 divided by 2?
To 6.5.
13 divided by 2, 6.5. Square that.
Oh.
Yeah.
It's 42.25.
42.25. Try type in 169 divided by 4.
See that?
Is 42.25.
Oh, same answer.
Yeah.
Interesting. Yeah, you're right. How did I get 169 over 4? Well, I squared the 13, I squared the 2. 169 over 4. Bah! But then again, you have a calculator, so you can actually tell your calculator what is 6.5 squared. And your calculator will tell you, oh, it's 42.25. There we go. That's it. We cool? Now, there is something with complete the square that I need to show you. And dash it all, I deleted my complete the square thing. That kind of sucks. All right. I'll tell you what, do that homework for now. Do all of that homework. Go back and watch the videos. They should make a lot more sense to you now. Okay? I gotta go and talk to this other kid.
Alright. I'll be sitting here doing this work.
Well, aren't you gonna meet up?